Okay, and okay, so the third one is compute the test statistic. So it gave me 3.309. Is that true?
3.09? Yeah.
I feel spoiled sometimes when it does all this work for me. I'm like, woohoo.
Serious.
The p-value of 0.00, oh sorry, 001. Sorry. 0.001.
Yeah, I got that too.
And for E, this be both tails, right? Both tails.
Yeah.
Okay, F.
So when it gives us this p-value, is it giving us the two tails?
That's a good question.
Oh, actually, you know what? If you change up the, you know when you say type of test, if you change that, it affects your p-value.
Oh yeah, yeah, that's right.
That's cool. So it really does do all of it. Wow.
I think alpha was 0.05, right?
Yeah, so we have to reject the null. So there's sufficient evidence to state that to reject.
Okay, construct a 95% confidence interval.
So what it gave me on the 0.044.
Yeah, 0.044.
0.165.
Yeah.
Okay, the interpret confidence interval you constructed. So isn't it saying that there's a 95% chance that the true mean of the two proportions lies within that interval?
I'm not sure. Was it like we are 95% confident? I don't know.
Confident. Chances are wrong. Answer right.
I hate it.
It's not. No, yeah, you're right. It's at 95% confidence. Sorry, just 1 second.
We're 95% confident that the true mean proportion lies within this interval. I guess true proportion. I'll pull up the answer key to make sure it's all correct. Okay. Yeah, no requirements. The both are equal. The proportions are equal.
Did you guys equal? Did you open the group quiz?
Oh, I was gonna check the. What the?
Oh.
They got a different p-value though.
Yeah.
Claire, they got a different p-value. They got 0.0009.
Oh, really?
Yeah, but the same z-score.
Well, what if we just the p-value that the computer gave us? Let's just yeah. If you give it one more decimal point, it goes 0.0009.
Oh, okay.
We just round it up then.
Difference in proportion.
So then did they still reject the null?
Yeah. Yeah, it looks like it's correct, pretty much. The last one's just kind of like a plan where there might.
Yeah. Okay, so I don't feel like before we take the quiz, there weren't really anything that was unusual about this lesson, right? It's just doing it with 2 instead of 1.
Mm-hmm.
Okay, I'm gonna open it up then. Unless, do we have any other questions on part 2?
No, I'm good.
Okay. Okay. So, tell me when you guys are on question 3 for the group quiz.
Yeah, I'm there.
Okay.
Yep.
The TC tasting. Let P1 be the proportion of females who can taste the PTC and P2 be for males. The research study question is given here. Is a proportion of females who can taste PTC different than that of males, so just not equal to, right?
Yeah, so all we're looking at is the column yes, right?
Yeah, you're right. So P1 equals 18 divided by 35. P2 would be 52. Wait. Oh, I read it wrong. Okay.
It's like 52 divided
52 divided by 70?
Yeah, I think it's total.
Is that right?
Yeah. Because, we're testing.
Okay, so then the total.
Population portion of
So then the column of total on the right, it's just like total of men and female, right? Which we don't need.
Yeah, I think.
So for girls, it's 52 with the.
Yeah.
So it's 52 divided by 70 for girls, and it's 42 divided by 59 for guys, right?
I think so. 42. Oh, 5p hat. He does one places. POP hat 1, which is. Did you get 0.743?
I got 0.743, yeah. So 0.74.
Well, I think you want the places, right?
Oh, 3.743. Okay, for number 2, I got 0.712.
I got that too.
Did you guys get 0.7122?
Yeah.
Oh, for the for B hat 2.
Uh-huh.
Yeah, I got 0.712.
Okay, for the next one I got the P equals, obviously the null is P equals, P1 equals P2, and for the alternative I got that they're not equal to each other.
Yeah.
But it should be P hat, right? P hat. Or is it just P? Oh, is it just population?
It's just population, I think.
Because we're trying to solve for the population and we use P hat to do so.
Yeah, I think it might be P equal P2 without the hat.
No hat? Okay, good. That was a good catch. Whew. Just got that wrong. Okay, so the confidence interval, I got 0.078. Oh, wait, no. Negative 0.122 and 0.84184.
They don't have it on there. I guess it's negative 0.123. This might be a rounding problem.
Yeah, they're a little bit off on both of them.
Did we choose the right numbers from
Yeah, I think it's a negative 123.
Oh, negative 0.123?
Yeah, I just am wondering why. Like, did we
Just a little
get
bit off.
something wrong? Yeah, it's not very off.
Maybe you want to try putting, well, I don't even know how you do that. You just see data. Never mind, I was about to say. Let's move on.
I was going to just move on. It's not fitting so well. So,
we
do we reject the null? Don't reject it.
I got the p-value of 0.693. So they'll
Me
reject
too.
the null.
So, fail to reject the null. Okay. Which of the following statements best describes the outcome of the study? There is insufficient evidence to suggest that the true portion is different from the portion of analysis. So I got the second one.
Yeah.
There is insufficient evidence to suggest that the true proportion of females is different from males.
For
question,
okay.
Hey guys.
Yes, Brandon.
Sorry, I lost connection there for a second. I lost connection.
No worries. I was wondering. I was like, man, where's? It was just quiet.
Oh yeah, no, sorry. What did we decide on 7? You said reject?
Yeah. Wait, no, we failed to reject it.
Oh, okay. Fail to reject H of A.
Failed to reject the null.
Okay. Okay, sorry about that. So for A, we decided there's insufficient.
Yeah.
And it's the
They're
one.
not.
It's different from the true proportion analysis. That
The
one.
different. Okay, the different, not the less.
Yeah. So insufficient evidence and then different from the true proportion.
Okay. Thank you.
Weekend. Die greater than proportion. Patients who have a heart attack and are admitted to the hospital on a weekday die. So that's P2 is greater than P1, right? You there?
What did you say? Yeah. What were you saying?
So our alternative hypothesis is P2 is greater than P1, right?
Yeah, I think so. Yeah, because P2 is the weekend one, right? The week. Yeah, P2 is a weekend, and they want to know.
Yes.
But
Okay. Let's see. First group P1 day.
so it's gonna be the died and the total, right? So P1 would be 16713 divided by the total for the weekday.
Yeah. Six, 1, 5, 2, 7, 7. P2. P1 is less than this.
So I had that all the requirements are met.
Yes, in here.
And then P2 is bigger than
That's
so
the first one.
for,
I think it's the first one. This, for number 10, I think it's the first one. I don't know if it's different than yours, but
yeah, that's what I had too. One is smaller than P2. Then for 11, I put one. I'm gonna put 0.141.
like 141, yeah.
And then for P2, I got 0.145.
Z-score, I got negative 2.020.
Me too. Negative 2.020. Brand, do you have questions about that?
I cut out for a second. Are you doing Z-score right now?
Yeah.
And to find the Z-score, are you just plugging it into that Excel sheet?
Yeah. So plug in the Excel sheet and let us know what you get. So, what's that?
Hey, real quick,
So,
is this isn't the one sample z-test, right? Or is it
no, it's the two proportions.
two
One.
proportion? Okay, because there's the two.
If you look at down at the bottom, it will say two proportions you can click on.
Okay, got it. Okay, this is really embarrassing. I do not know how to use this thing.
What? Sorry.
It's really embarrassing, but I'm not quite sure how to use this thing.
No worries.
Like,
So the only thing that you change is the blue cells. So see how there's just like under inputs, there's 6 blue cells.
uh-huh. One and N1.
Yeah, exactly. So you go to the problem and you figure out what they're using for in their first population. And in this lesson, or in this question, so it says, and in problem 9, it explains that P1 is, do you see that? Do you see where it explains P1?
What's that?
Let P1 be the, do you see in question 9 it explains P1?
Yes.
Yeah. So P1 is those that are over the weekday, right?
So 0.141.
Yeah, that's the answer we got. But I was just explaining, if you go to question 9 and you look at it,
Uh-huh.
it shows you the data to put into the Excel spreadsheet.
Oh, I see what you're saying. Okay. That is.
So X1 is gonna
Oh,
be,
I see. I see. Okay.
yeah, so that's fine. So X1, so they're saying for P1, we're gonna use the weekday. So you take how many died divided by the total. And so you would plug into the Excel sheet 16713 with the N for 1 being 118519.
Gotcha. Okay. Yeah, plugging it
And
in.
then as you, yeah, that's fine. And then as you change that, it will change all these other cells, and they'll give you all the answers that you need.
Convenient.
It's not pretty good. Yeah. Thank you. I would check it out. So Colby, what side would you say that we
Well,
shade?
the probability it gives us, so whatever we shade, that would give us, I guess that'd be the area, and that area give us, p-value. P-value that we're given, it just, it's very small, it's like 0.022. If we're to the right
So probably
of
to the right or to the left.
if it was to the right of negative 2.020, then it'd be like
It'd feel.
like 90, like 0.9.
That's a really good point. Okay, yeah. So because I was trying to think of that, and I was like, I'm not sure, because if you do a one proportion or like a one sample, like where that sample is, like if you're looking for above. But because we're the mean of the two, I'm like, I don't know, like what are we looking? What's the number we're looking for? But that's a great way to dissect, like figure it out. So the p-value then. So fortunately, I said to the left. Let me make sure I click the right one. And then 15. Brandon, did you get to type it all in?
Yeah. negative 2.020.
Oh, if you do it the other way, if you do P1 is greater than P2, you get 0.978.
Oh.
Oh, there you go. Perfect. Yeah, so Brand, that's the right z-score. So next to it, one thing you got to make sure that you do is up under inputs, it says a type of test.
Yeah.
And if you put in, that's pretty much your alternative, your alternative hypothesis.
Yeah.
If you put in the wrong answer, it will change your p-value. So for this one, you got to make sure that p is less than p1 is less than p2.
Okay, yeah, I have it as P1 is less than P2.
Okay, perfect. So what's your proportion that the p-value you got?
I got 0.022.
Yeah, that's what I got.
Okay.
Perfect. And so with this, we reject the null hypothesis. Is that what you guys got?
Yes.
Yeah.
Awesome. So there's sufficient evidence to conclude that the proportion.
Okay, so there is sufficient evidence to conclude that the proportion of patients who have a heart attack and are admitted to the hospital on the weekend who die is greater than the proportion of patients who have a heart attack and are admitted to the hospital on a weekday who die.
I think that's the right one. It's greater.
Then
Yeah.
there's another one too. See, there's sufficient evidence to conclude that the proportion of patients who have a heart attack and are admitted to the hospital on the weekend who die
Are the same.
the same. So it is in that one. It's the same. So
Yeah, so the first one, right?
yeah.
My only concern is the very first problems that we did, like 3 and 4. I hope they didn't round differently than us, but what do you do? Okay, so shall we submit it?
Sure.
Yeah, I have a question on 14 real quick.
Yeah.
How did we determine which side that we shaded?
Oh, Colby explained it really well.
Well, it was just kind of using like the p-value to give. So if we believe that we interpret what they're saying about their research question that p1 is less than p2, the probability that we got, the p-value that we got was 0.022, which is very small. And the z-score we got was negative 2.02, so it's on the far left. So if you shaded to the right of it, that corresponds to a large p-value. If you shade to the left of it, it corresponds to a pretty small p-value.
Ah.
So that's just like looking
Alright.
working out. Other than that, I don't know how to distinguish. I guess. I don't know.
Okay. Yeah, makes sense to me.
Yeah, I think that's the best way to look at it. Just like we already know the z-score is negative, so
Yeah.
gotta go.
Alright. Good enough for me.
Okay. Yeah, that's what I said. I was like, oh, that's a great idea. Yay! Good job, guys.
Excellent.
Wow, that went a lot quicker than previous weeks. I think it was also just a good
Yeah, it did.
week.
Very simple. Simpler than I think it was like was it 2 weeks ago when we first started talking about categorical data.
Yeah.
You have to kind of go through like the theory of it, how it all works.
Yeah.
Yeah.
Oh yeah. So our collected data is due on
Oh yeah.
worksheet, but it's due on the 28th, which I believe is this week. Yeah. This
Oh
Saturday.
yeah. Fran, do you know what we're doing for our project? Have we explained that to you?
Yeah. What's the plan with that?
So we decided, okay, wait, I gotta remember what we did. We decided to see if each bag of like, like a bag of Skittles you can get at Walmart, if they all
Yeah.
have the equal number of like purple, orange, green Skittles.
Ah, smart.
So we all have to buy 10 bags of Skittles. Is that what we decided, Colby, or what did we decide?
Yeah.
I can't remember, Paul.
Yeah, it was 10 because we're gonna have 30 bags.
Yeah, okay, because or else we'd have like 100 if we got the boxes. So we buy 10 bags of Skittles at Walmart, the closest Walmart to you, and we're all gonna do Walmart ones. That was part of the data to keep it, um, like to rule out variables.
Yeah.
So we go to the closest Walmart. You buy 10, and then you count. Keep count, and for each bag, figure out how many total Skittles, and then how many of each color.
Okay. That's doable.
So maybe should we try to get our data together by Thursday, and so that way we can all make sure we're submitting it with a similar format.
Mm-hmm.
Yeah.
Does that sound okay?
Yeah, that's fine with me.
Yeah, we'll have to turn in before Saturday because I think Island's down on Saturday.
On Saturday?
Yeah,
Oh,
with the
that's
student.
good to know. Okay, yeah, so let's try to. Can everyone buy the Skittles and count them by Thursday?
Yes.
Yeah.
Yeah, I'll need to grab them tomorrow. And then that way we can try to submit it before Island's down. I'm glad you saw that, Colby. I had no idea.
Yeah, thanks, Colby.
Oh, cool. Okay, sounds like a plan. How do you like that idea, Bran?
Sounds good to me. I really like it. Well done.
Good. I must have been hungry because I kept suggesting food ideas when we were deciding.
It's the easiest. So many, easier ideas. Not a lot of work.
Yeah. Hey, were we gonna, Bran? We had to talk about like how we were gonna pick the bags from Walmart so that it's random. Colby, what did we decide, or what did you submit? Are we gonna be like doing a randomizer on our phone so we know what one, or should we just pick the first 10?
Well, yeah, we're gonna use like a random number generator. I guess it all depends on like how many bags are on each layer, because it's layered. I don't even know how big the box is either, so I guess it depends all on that.
Yeah.
So.
Yeah. Well, I'll go tomorrow, and then I think as long as we do the randomizer on our phone, I can let you know how we get it. I think it will end up being pretty random either way.
Yeah.
Not too concerned about it. Also, I did notice that it said in the last collected data that you're supposed to mark down who's responsible for each thing, both like out of like responsibility and legally. So maybe we should, like I was thinking about nominating you or Brand as the legal person, so that if we got sued in any way, you guys take all legal responsibility.
I'm gonna see if you're taking it pretty seriously.
I know. Like, whoa. She must have had some pretty crazy ideas in the past.
Yeah.
So, cool. Well, awesome. Okay, we'll see you Thursday, and I guess we'll have all this fun Skittle data.
Mm-hmm.
Right.
Okay, talk to you guys later. Have a good night.
Okay, good work, Claire. Thank